What if I told you there's a book, a single book, that's basically the answer key to the entire universe? Well, today, that's what we're diving into. Sir Isaac Newton's Principia Mathematica. Now, this wasn't just another dusty old text. Oh no, this was a full-blown revolution that showed the universe wasn't playing by two different sets of rules. It proved that the very same laws that make an apple fall from a tree are what keep the planets locked in their orbits.
You know, for thousands of years, humanity looked up at the sky and saw one thing, and then looked around on Earth and saw something completely different. Up there, you had the stars and planets moving in this perfect, silent, predictable dance. But down here, well, our world felt chaotic, messy, and totally unpredictable. So the thinking was, they must be two different places with two different sets of rules. Simple as that. But was it true? And then, bam! In 1687, Isaac Newton drops this absolute masterpiece. Its title basically means Mathematical Principles of Natural Philosophy, which was a huge deal. He was saying, I'm going to use the cold, hard language of math to explain the real world. It was a promise to deliver a single unified theory for everything, from that falling apple all the way to the moon. So, let's see how he pulled it off.
So yeah, before Newton, the cosmos was really split in two. You had our world, the terrestrial realm, where things fall down, they slow down, they break. They're imperfect. And then you had the heavens, the celestial realm, where everything was thought to move in perfect circles, forever, guided by some kind of divine perfection.
And that right there was the grand challenge. I mean, really think about it for a second. What on earth could possibly connect a piece of fruit dropping to the ground with this massive rock just hanging out in the sky? The absolute genius of Newton was that he suspected they weren't different at all. He believed they were two sides of the exact same coin, governed by the very same invisible force.
To even begin to build a universal theory like this, Newton knew he couldn't just use vague ideas or philosophy. He needed something solid, something precise. He needed math. So in the first part of the Principia, he doesn't even talk about planets or stars. No, he starts by building a brand new language for physics, literally from the ground up.
And this might sound a little dry, but it was absolutely revolutionary. Instead of just throwing around words like force or matter, Newton nailed them down with mathematical rigor. He was building a logical foundation, brick by brick, making sure every single part of his argument was completely airtight. So first up, he defined what he called quantitas materia, or the quantity of matter. Today, we just call it mass. And he was really clear, this is an intrinsic property of an object. It's the amount of stuff it contains. This was a huge step because it separated an object's inherent mass from its weight, which, as you know, can change depending on where you are.
Next, this impressa, or impressed force. Now, listen closely, because this is a really key distinction. For Newton, a force isn't something a body has, it's something that happens to it. It's an external action, a push or a pull, that changes how an object is moving. If there's no impressed force, an object's motion just doesn't change, period.
Okay, so with these super precise definitions locked in, Newton could finally start to build. And he laid out 3 simple, universal rules or laws that would become the absolute bedrock of physics for the next 200 years.
First, the law of inertia. Basically, an object is lazy. It's going to keep doing whatever it's already doing unless something messes with it. Think of a hockey puck on perfectly smooth ice. It would just glide forever. Second, the law of acceleration. If you want to change that motion, you need a force. The change you get, the acceleration, is directly tied to how hard you push. Yep, that's the famous F equals ma. And third, the law of action-reaction. For every action, there is an equal and opposite reaction. If you push on a wall, that wall is pushing back on you with the exact same force. These 3 laws together, they create a complete system for describing all motion.
And just like that, those 3 simple laws didn't just explain motion. They completely shattered the old worldview. The idea of 2 separate universes, gone. Replaced by a single cosmos governed by one set of mathematical laws that worked everywhere. All of a sudden, motion wasn't some deep philosophical mystery anymore. It was predictable. It was quantifiable. It was a science.
So, after laying down his mathematical principles and his laws of motion in the first 2 books, Newton was finally ready for the main event. In Book 3, which he called The System of the World, he aimed his new physics at the entire cosmos.
And this was the masterstroke. This is where it all comes together.
He proposed that the same force that pulls an apple to the ground is the very same force that holds the moon in its orbit, that holds the planets in their orbits around the sun, that holds entire galaxies together. And he gave it a name: universal gravitation. He identified gravity as a kind of vis centripeta, or centripetal force, which just means a center-seeking force. See, according to his own law of inertia, the moon should just be flying off in a straight line into deep space. So why doesn't it? Because the Earth's gravity is constantly pulling it inward, forcing it to perpetually fall in a curved path around us. That's what an orbit is. It's just falling sideways, forever.
And here's where you see the sheer, mind-blowing power of this one single idea. Suddenly, all these cosmic mysteries just clicked into place. The orbits of the planets? Solved. The weird paths of comets? Solved. Why the tides rise and fall? Solved. Why a stone picks up speed as it drops? All of it. Every single one was just a different expression of the exact same force: universal gravity.
Now, the impact of the Principia went way beyond just science. It didn't just change physics, it fundamentally changed how humanity saw the universe, and really our place within it.
The result was this profound shift in thinking. Newton had revealed a universe that wasn't chaotic or mysterious at all. Instead, it was this intricate, elegant, and predictable machine, a giant clockwork. And this idea just lit a fire during the Enlightenment, because it suggested that if we used our reason, we could figure out the rules of creation itself. If you knew where all the gears were and how fast they were moving, you could, in theory, predict the entire future of the cosmos.
Newton himself summed up his entire revolutionary method right there in the preface. He's basically saying the whole point of science is to first observe the world, then use what you see to figure out the underlying rules, the forces of nature, and then, once you have those rules, use them to explain and predict everything else. That's the blueprint for modern science, right there.
For more than 200 years, Newton's clockwork universe was king. His laws seemed like the final answer. But they described a world of absolutes, of perfect predictability. And that leaves us with a really fascinating question. What happens when you zoom way, way out to the cosmic scales of gravity? Or zoom way, way in to the bizarre world of atoms? What happens when the machine gets stranger and more complicated than Newton could have ever dreamed?